Hey guys, welcome. This is midterm practice test 2. So let's get to it. These numbers don't correspond to the section, so just don't let that throw that off. This should be question 1 or close to it. So it says, what are they trying to do? It looks like this is a proof. And what essentially are they trying to prove? Well, if I get to the very end, I notice that x plus y plus z looks like they added up every angle, and that's the triangle sum theorem. So it looks like the theorem that they are trying to prove is the triangle sum theorem. So that's why I'm going to pick the triangle sum theorem. So, but could they ask you a slightly different question, like how do you prove it? And that answer is yes. So this would be how you prove it. So let's go each step one by one. What's the measure of angle AB? X is equal to that, right? That's given by the picture. So remember, given statements come from the picture. And Y is equal to this angle, right? That's given. And so then it designates this one as my third angle, and it adds them all up. We know that they all have to add up to 180. That is this triangle sum theorem. Okay. Next question. I think it's either this one to the left or bottom. We'll do this one next. Okay. It says find the value of x. So we look here and we notice that 2 of the angles are equal. So that means these two sides are equal. That's the converse isosceles triangle theorem. Well, you might be thinking, wait a minute, what's the isosceles, the regular isosceles theorem? That's if these two sides are equal, then we know these angles are equal. We can imagine we could fold it right there, and this side would fold on top of that side. Okay, so to solve for x, let's set these equal to each other, and let's not set them equal to 10, because that's the other side. That one is different. Okay. So 7x plus 5 has to equal 3x plus 21 because of the converse theorem. Let's get the x's on one side. Right, and then, all right, I'm getting close here. Divide by 4, and I get 4. So there's my answer. A, x is 4. What about the third question? In a triangle shown, if angle A is 34, so if angle A is 34, let's zoom in, then let's figure out all these angles, right? This one's 90, and I should be able to figure out this one. All of those angles, just like we said, triangle sum theorem, all those angles have to add up to 180. So if A is 34 and C is 90, we can figure out what B is by subtracting them from 180. So angle B, if I combine these and I subtract, I get 56. Okay. Now I can compare this triangle to that triangle by looking at its evidence. So it looks like these two hypotenuses match, and it looks like these two legs match. So the hypotenuse leg theorem, congruence theorem, states that their corresponding parts, states that they're congruent. So triangle, I got to go on the right order though. Triangle ABC, so the 34 angle, across this one, and then to the right angle. So I have to go start with an angle that's 34. I don't know which one that is, but I have to finish off at the right angle. And notice, to go to ABC, I went across this one and then across the side that didn't have a mark. So I actually have to go this way, across the one and then across the side that doesn't have a mark. So DEF. So now this should help me figure this out. Angle A and angle D are both 34 degrees. Angle B and angle E are both 56 degrees. And last, both angle C and angle F are 90 degrees. Those are the corresponding angles. So let's see. They want to know what angle D is. So angle D is 34 degrees. So it looks like they kind of flipped this over and spun it around. Right? All right. Next one, it says, given that angle 1 is 130, what would 7 and 5 be? Okay, so we said in class that any big one, all the big ones, as long as these are parallel, and they are, all the obtuse angles are equal to that, and all the acute would be equal to that. All right, so this is 130, 130, 130. And all the acute are supplements, meaning they add up to 180 with the big ones, right? So 7, it looks like, is 50. 7 is 50. And 5 is 130. So we just got to find the one. 5 is 130. Okay, I like that. 7 is 50. I like it. That matches our answer. Nice work. Okay, we look at the next question. What are the coordinates of point C that's located 1/4 of the distance? All right, so let's graph this. -1, +2, that's A. Where's B? Okay, 4, 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8. So here's a rough sketch. This is where B is. So we can see here that the distance between 2 and 8 is 6 if we subtract. So this distance is 6 because I went from 2 up to 8 in the y, right? And this distance, I went from -1 to +4, so that's 5. Now this one's not going to be as easy to cut in half, and I not only need to cut it in half, I need to cut it in 4s, but I end up right about here, right? So it looks like I'm at about not quite 1, but maybe a half a 1, and then it looks like I'm up 1, 2, 3, and a little more. So my guess is D. That's kind of my guess. Now, what's another way to do it? Well, be a little bit more precise, use graph paper. But another way we talked about in class is 1/4 would be the same as cutting this in half and then cutting it in half. We can do that with our coordinates. So to cut A in half, right, we add the 2 x's and we cut it in half. We add the 2 y's and we cut it in half. So that would be 3/2 and 10. So 1.5 and 5. Okay, so that's the coordinate of this. 1.5, 1.5, and 1, 2, 3, 4, 5. That looks right. Now I'm going to find the middle between A and that midpoint. So back to A, and this midpoint. Let's find the middle of that. So I'm going to add the 2 x values and cut it in half, and then add these 2 y values and cut it in half. So I get 7/2, which is 3.5, so I like it, right? And then if I add that, I get 0.5 divided by 2, and half of 0.5 is 0.25. Beautiful, that's our answer. I think we've done this question before, so that's a good review. Which step is not in an angle bisector? So this one we've done before too. I can make an arc, I can make an arc from A, right? And then I can make an arc from B and an arc from C. And that intersection point, I can make a ray through there. And this ray, AD, is the angle bisector. It cuts that angle in half. So let's think of this. Which one wasn't one of the steps I went through? And it's this tricky part. Notice I can't make these 2 arcs with different sizes. I have to make sure to keep my compass the same. Openness. So I definitely have to reject C. And I feel like we've had this one again. So it's a good review right before the test. Okay, next question. Does a heptagon have the following types of symmetry? Okay, I feel like we did this one in class too. 1, 2, 3, 4, 5, 6, 7. Okay, that's a heptagon. Hepta, again, means a 7-sided shape. Because it's an odd shape, notice I should be able to fold it there, or all 7 from all 7 points. Does it have point symmetry? And that one I'm going to have to say no, because it doesn't look the same upside down and right side up. In fact, it just looks like an upside down septagon. Notice it's flat on the bottom and pointy on top. So when it's upside down, it's pointy on bottom and flat on top. It's not going to look the same upside down and right side up. So I get a yes and a no. That's B. Nice. All right, next one. What's the least angle of rotation that maps a heptagon? So I'm back to this 7-sided shape on itself. So our formula is 360 divided by n, and we know a heptagon is n is 7. So we need a calculator. If I take 360 divided by n, the nearest whole number is 51, right? Nice. Okay, let's take a look at the next one. How many lines of symmetry does the heptagon have? Well, it looks like 1, 2, 3, 4, 5, 6, 7. I could fold it on any one of these lines, and it will fold on top of itself. So I'm going to pick 7, and I hope you did too. All right, next one. In the figure shown, what is the value of x? So let's look at our evidence though first before we do. It looks like we have one side that matches one side, another side that matches another side, and an angle here that matches an angle there. So this evidence spells side, angle, side, triangle congruence. Now that we know that those are congruent, so let's see, well, what triangle is congruent? If I name the triangle going across the one side to the angle I know about and then the second side, I'd call it BAC. So using that same order across the first side to the angle I know about and then across the second, this would be called EDF. So notice here that BC, first and last, that side, this one with the expression 9x minus 17, and EF, first and last, have to be equal because they're corresponding parts of congruent triangles. So we should be able to set these equal and solve for x. So let's do it. There's our answer. Nice work, guys. Next one. What are the angle measurements here? So notice we can say these two angles are equal, so these two expressions have to be equal. That's the isosceles triangle theorem. Okay. So I'm going to set these equal to each other. And I need to get x on one side. And I need to get x by itself. And so x is 10. Okay, so I can now plug this back in, back in, and plug it back in. So 5 times 10, take away 12, 38. 2 times 10 plus 18, 38. That makes sense because I said these angles are equal, right? And this last one, 9 times 10 plus 14. 90 plus 14 is 104. Let's look for our answer. There it is. We could also add those up and just double check they should add up to 180. So 38 and 38 is 76. And 104 plus 76 is, yep, you guessed it, 180. Nice work. All right, let's look at another one. Coordinate A is 2, -1. 2, -1, that's A. Coordinate B is -1, 1, okay? Where would be the midpoint? So if I draw a line here, it looks like the midpoint would be somewhere here. I didn't draw that perfect, but somewhere there. So that looks like maybe 0.50, 0.50. Okay, so that's my guess. Now let's verify using the formula. So the formula says I can add the two x values, right, and divide. I can add the two y values and divide by 2. That's going to be my midpoint. So -1 plus +1 is 0. So that would give me 0.5 and 0. Oh, I was right. Nice. All right, what do we got going on here? It looks like 2 lines cross. Well, anytime 2 lines cross, you have vertical angles. So the opposite angles should be congruent. So hopefully you set these equal to each other. Okay, I still got to get x by itself. So what have I done? Let me start over. I feel like I made a mistake here. Okay. X plus 20 is equal to 3x plus 8. Okay, I think I wrote 3. Sorry about that. I'm tired. I've been doing math a long time. It is late at night. Okay, subtract 8. I get 12. Ooh, okay, so it looks like x is going to turn out to be 6. So they want me to solve for PTQ. PTQ. So that's this angle right there. So I can plug in x is 6, and I get 20 plus 6, which is 26. Nice. All right, we had ourselves another triangle. What do we got here? I need to solve for A. Well, we know the triangle theorem, sum theorem states that all 3 angles should add up to 180. So if A is 3x plus 10, we can substitute, and B substitute, C substitute. Okay, so we have a lot of things to combine. I've got 2 x's and 3 more x's, so that's 5 x's. 10 and another 15, so that's 25. And I've combined like terms. Okay, that's also called simplified. Now we're just going to do our little, subtraction property of equality. Divide by 5 on both sides. Nice. So I get 31. But that's not what they've asked me. They've asked me to solve for A. So I can plug this in, 31, right? 3 times 31 plus 10. So that'd be 93 plus 10 makes 103. Nice. All right, now I could try these other ones out. 31 plus 15 would be 646. And this is x, which is just 31. And just to be like, listen, I'm like a little worried if I'm right. I think I'm right. They want angle A. Let me double check my math. So let me add up all 3. Yep, okay, I'm right. They should all add up to 180, and they do. Okay. 10, what would be the perimeter? So let's take in the given information. It says given this distance is 6. Given this distance is 14, okay. Given this distance is 6. So we actually have 2 congruent sides. 6 is congruent to 6. We know that the only angle that's supplementary or makes a straight line with 90 is 90. So these are both the same angle, right? And we have reflexive. This side and this side are shared. So based on side angle side triangle congruence, it looks like this triangle on the right, CFD, is congruent to this triangle on the left, EFD. So this tells me first and last, CD, which is 14, should match first and last, ED. So they both should be 14. So I should feel comfortable writing 14 there without providing evidence. Now I can find the perimeter. So the perimeter is equal to all the way around. So this is 6 and another 6, so that'd be 12 for this side, right? And another 14 and another 14. So let's add that up. 12 plus 14 and then another 14. I get 40. Nice work, guys. We're getting ready for this test. We're going to be ready. All right. I think just a few more. So let's look. This one's probably the toughest one. Select all the true statements. Okay. So let's see. I've got an alligator mouth here. Here's the top of the mouth. There's the bottom. So here's where my hinge is. And I can compare it to this one. Here's the top of the mouth. Here's the bottom of the mouth. So there's my hinge. And notice, let's look at this stick. This stick is 11. This stick is 13. So what that tells me is this angle at E, it has to be smaller than this angle at A. Because 11 is less than 13, I'm ordering the sides, right? Then I know that opposite the side of 11, this 4x plus 5, has to be smaller. This angle E has to be smaller than the 45 degrees, which is the angle at A. So when I think about this, they can't be equal, so I'm not going to pick that one. Now, what's happening over here? Notice this triangle, I think, is congruent to that triangle, meaning totally equal, same size alligator. The reason is this angle and this angle have to be equal because of vertical angles. And now I have side angle, side, side angle, side. So these actually are congruent triangles. That kind of snuck up on us. There's two concepts in this problem. CED has to be the same triangle as GEF because of side angle, side triangle congruence. So that means using CPCTC, CD first and last has to equal GF first and last, and they both have to equal, or FG. So this one has to be true. This has to be 11. So what else do I know is true? Well, they're trying to say here angle B and F are equal. B and F. Well, we know those are different. We knew absolutely these two triangles are the same, but this one and this one are different. So I'm not going to pick this one. Now let's see what else. Would angle D be the same as F? Would this angle be the same as that angle? Well, yeah, they're both in the same. That would be another CPCTC. They're both corresponding parts of congruent triangles. So I'm going to say yes there. Last one, is A bigger than E? Well, we said, yeah, A is bigger than E. So we're going to select that one. So my answer is B, C, and D are true. Nice. Okay. Now let's see. It says if these are parallel, so if they force this to be parallel with this, find angle 1 and 2 added together. So this is vertical. That would be 20. This is 60, so this would be 60, right? Just vertical angles. And if this is parallel, it makes a Z. This angle and this angle are congruent. So this has to be 20. So if the measure of angle 1, we said angle 1 has to be 60. And we want to add it with angle 2. And we just proved that angle 2 is 20. So what would be the sum if we added these together? I get 80. Cool, right? And the reason why this one is 20 is that makes a Z. Again, that should help us if these two are parallel. That's alternate interior angle theorem. And we know those are congruent. Ooh, okay, last one. This is exciting. Let's look at our evidence. So we have a side that matches a side. nice, an angle that matches an angle, and a side that matches a side. So that means that BAC, this triangle has to be congruent to EDF. EDF, because of side angle side triangle congruence. Now, can I set I'd like to set these equal to each other, but I'm not sure, so let's make sure we can. Is side BC first and last congruent to EF first and last? Yes, that would be a corresponding part of congruent triangles, and they would be congruent. So I can say that that is congruent to 23. So I can set this up and solve. Best of luck on your studying, guys. I'll see you soon for the exam. Get lots of good sleep. Take care, guys.